Most people think they already know Saturn. A pale world wrapped in cloud. A ring system unlike anything else in the solar system. For more than 400 years, those rings have defined the planet. They are the first feature every telescope finds, and the first detail almost every book remembers. But the rings point almost everyone toward the wrong mystery. When the first spacecraft reached Saturn, their cameras returned extraordinary images of the rings. But another instrument was looking somewhere the cameras could not. It was measuring heat. Every second, sunlight pours onto Saturn. Every second, Saturn sends heat back into space. Those two numbers should nearly balance. They do not. The planet radiates far more energy than it receives from the sun. Not a little more. Enough to force a completely different question. The rings suddenly become irrelevant. If Saturn is producing that much extra heat, something inside the planet is still working. That contradiction became the real investigation. The first instinct was caution. Spacecraft travel for years through radiation, vacuum, and extreme temperatures. A single instrument can drift out of calibration. A damaged detector can manufacture a mystery that never existed. One unexpected measurement proves very little. Then another spacecraft crossed Saturn. It found the same imbalance. Years later, a more advanced mission mapped Saturn's infrared emission with far greater precision. The numbers changed slightly. The conclusion did not. Different spacecraft, different instruments, different decades, the same hidden surplus of energy. By then, the anomaly no longer belonged to one mission. It belonged to Saturn itself. The planet absorbs only about 2.5 watts of solar energy for every square meter facing space. Yet it releases well over 4 watts from the same area. That missing energy cannot be found in the sunlight arriving at Saturn. It has to come from somewhere else. The rings still looked exactly the same. Bright, thin, frozen. But they had quietly lost their place at the center of the story. They explained why Saturn was unforgettable. They did not explain why Saturn was warm. One possibility still remained. Perhaps nothing unusual was happening at all. Every giant planet is born hot. As it slowly contracts under its own gravity, it releases the energy trapped during its formation. Jupiter still shines this way today. Saturn should be no different. It was the simplest explanation available. Researchers reconstructed Saturn's entire thermal history, allowing the planet to cool naturally from its birth more than 4.5 billion years ago. At first, everything behaved exactly as expected. The young planet glowed intensely. It steadily lost heat. Its brightness slowly declined. Nothing appeared out of place. Then the model kept moving forward through time. By roughly 2 billion years, Saturn had already surrendered much of its original heat. Around 2.5 billion years, the simulated planet approached the level expected from ordinary cooling alone. The real Saturn had another 2 billion years still to survive. When the simulation finally reached the present day, the gap was impossible to miss. The model had become too cold. The spacecraft had not. Researchers adjusted the starting temperature. The difference remained. They tested different estimates for Saturn's deep interior. The gap remained. The calculations changed. The contradiction did not. Without another source of energy, Saturn should have cooled to its present state billions of years before today. The first explanation had survived for decades. It did not survive the measurements. The extra heat was real. Ordinary planetary cooling could not account for it. Whatever had kept Saturn warm was still operating. And whatever it was, it had been working in complete darkness for billions of years. Sunlight had already been counted. The rings had already been measured. Ordinary cooling had already failed. The only place left was somewhere no spacecraft had ever seen. Inside Saturn. The planet looks enormous from orbit, but almost everything that defines its appearance exists within a surprisingly thin outer layer. Beneath the bright clouds, pressure rises with astonishing speed. Every kilometer downward transforms hydrogen into something less familiar than the layer above it. The deeper the reconstruction went, the less Saturn resembled the giant ball of gas it appeared to be. Gravity became the guide. No camera could see through Saturn's clouds, but the planet's mass could not hide completely. Tiny variations in its gravitational field revealed how matter must be arranged below the atmosphere. Those measurements narrowed the possibilities until only a handful of interior structures remained physically consistent with the observations. Far below the clouds, pressure climbs beyond 1 million times Earth's atmosphere. Here, hydrogen changes. The transparent gas becomes an ultra-dense metallic liquid capable of conducting electricity. Nothing about this environment resembles weather. There are no empty caverns, no underground seas, no hidden chambers waiting to be discovered. Only an immense, continuous interior compressed by the weight of the entire planet above it. If Saturn's missing energy still existed, it almost certainly existed here. Then another observation quietly entered the story. It did not involve temperature. It involved helium. Hydrogen and helium formed together when the solar system was young. Both giant planets inherited nearly the same primordial mixture. Jupiter's atmosphere still preserves a helium abundance close to that original composition. Saturn does not. Measurements of its upper atmosphere consistently found less helium than expected. The discrepancy was not dramatic enough to become a headline, but it refused to disappear. As newer observations reduced the uncertainty, the result remained. Saturn's cloud tops were genuinely depleted in helium. At first, the two discoveries appeared unrelated. One described missing heat. The other described missing helium. Neither measurement explained the other. Yet they shared one peculiar characteristic. Both pointed below the clouds. The atmosphere was no longer simply the outer skin of Saturn. It had become evidence. Something inside the planet had been changing its composition for billions of years. The mystery had acquired a second clue. The first said Saturn was too warm. The second said part of its helium was no longer where it should have been. One hidden process would have to explain both. The answer did not arrive from another spacecraft. It emerged from a place much closer to Earth. Inside laboratories built to recreate pressures that exist naturally only within giant planets. Researchers compressed hydrogen and helium to extraordinary densities using powerful shock experiments, while increasingly sophisticated simulations followed the same materials under conditions impossible to sustain for long in the laboratory. Again and again, the same transition appeared. Hydrogen and helium did not remain perfectly mixed forever. Beyond a critical combination of pressure and temperature, helium could no longer stay dissolved within the surrounding metallic hydrogen. The mixture separated. Not violently, not suddenly, quietly. Tiny droplets of liquid helium began forming inside the metallic hydrogen itself. Only now does the hidden process receive its name: helium rain. The name is deceptively ordinary. Rain belongs to clouds, to weather, to open skies. Nothing like that exists where this process unfolds. Thousands of kilometers beneath Saturn's visible atmosphere, helium is no longer content to remain part of the surrounding fluid. It condenses into dense droplets suspended within an ocean of metallic hydrogen. No camera has ever seen it happen. Its existence had to be inferred before it could ever be imagined. Then gravity takes over. Helium is denser than the hydrogen surrounding it. Every droplet begins a slow descent toward the planet's center. Not in seconds. Not in hours. Across immense distances through an interior so dense that the journey itself becomes part of Saturn's energy budget. Something subtle happens during that descent. Every object that falls loses gravitational potential energy. On Earth, that energy disappears almost unnoticed. Inside Saturn, multiplied across an entire planet and sustained over billions of years, the amount becomes enormous. The falling helium does not create energy. It converts gravitational energy into heat. That single distinction changes everything. No hidden nuclear reactions are required. No unknown source of power has to be invented. Gravity, acting on material that is slowly separating inside the planet, is enough. Suddenly, the two contradictions stop competing with one another. The atmosphere contains less helium because helium is leaving the upper layers. Saturn radiates excess heat because that same helium releases energy while sinking deeper into the planet. Neither observation stands alone anymore. Each completes the other. But a convincing mechanism still has to survive the measurements that created the mystery in the first place. Researchers returned to the planetary evolution models that had failed so completely before. Nothing about Saturn's age was changed. Nothing about the spacecraft observations was adjusted. Only one new ingredient entered the calculation. Helium was now allowed to separate from hydrogen and settle toward the interior throughout the planet's history. The simulation began again. A young Saturn emerged hot from its formation. It cooled. It radiated energy into space. But this time, another source quietly replenished part of what was being lost. The cooling slowed. Not because the planet trapped more of its original heat. Because gravity continued paying out energy as helium slowly descended through the interior. The predicted cooling curve changed. Instead of becoming too cold, billions of years before the present, the simulated planet remained warm enough to resemble the Saturn measured by infrared instruments. For the first time, the observations and the physics arrived at the same destination. The excess heat no longer floated above the calculations as an unexplained anomaly. It became the natural consequence of a planet whose interior had never truly stopped evolving. The mystery had been solved. The measurements that once pointed in different directions were now describing the same planet. Infrared observations showed Saturn releasing far more heat than sunlight alone could supply. Its upper atmosphere contained less helium than expected. High-pressure physics revealed that helium naturally separates from metallic hydrogen under the conditions deep inside the planet. Planetary evolution models reproduce Saturn's present brightness only after that separation was allowed to release gravitational energy over billions of years. Each result had arrived independently. None had been designed to prove the others. Yet all of them converged on the same explanation. Not every detail is settled. Researchers continue refining the exact depth where helium first becomes immiscible. They continue investigating whether the descending helium forms a distinct layer above the core or gradually mixes into deeper regions. Those questions remain open. The central contradiction does not. Saturn's excess heat no longer requires an unknown source of energy. It requires a planet that is still changing beneath its clouds. The rings return one final time. They still stretch across hundreds of thousands of kilometers. They still dominate every image ever taken of Saturn. They still make the planet instantly recognizable. Nothing about them has changed. Only what they frame. Behind that familiar disk of ice lies a world that has been quietly converting gravity into heat for billions of years. A process no telescope has ever photographed, yet one written into the planet's temperature, its atmospheric composition, and the way it has evolved across the age of the solar system. The rings were never the answer. They were the reason we kept looking. Saturn drifts through the darkness exactly as it always has. Its appearance remains unchanged. The mystery does not.